Consuelo, athletes, beginning of chapter 4. If you don't have factoring down cold, I really wouldn't go on, okay? But it's up to you. Okay, what we're going to talk about is quadratic function graphs. The first thing I want to say is this. It is not, and I say this often, it is not enough to know how to do something. You have to know when to do it, okay? So in other words, you can know how to graph a line, but if you don't write this down, if you're taking this and graphing it as a line, you're just wrong because it's not the equation of a line, okay? You have to know when to do whatever it is you're supposed to do. And I've already shown you what makes, so if you can go back and look at the beginning, the very beginning of your chapter 2 notes, how to identify equations. You should know when you're looking at a polynomial equation, and specifically a linear equation, which graphs as a line, and a quadratic equation, which graphs as a U shape. You should also know when you're looking at an absolute value equation, which is a V, a square root equation, which is kind of like a half curve on its side, okay? If you don't know that, it's like you're not going to know how to do this. It's not enough to know how to do something. You have to know when to do it. So what are we talking about in this chapter? Quadratic functions, okay? What's a quadratic? Now, I know this is kind of weird. You know, quadratic, you'd think 4. There's like maybe x to the 4th. No, quadratic is an x squared, okay? So we're talking about x squareds. Now, it may be this. Don't write this down, but y equals x squared plus 3x plus 7, okay, where the largest exponent is x squared. You could have an x in it also, okay? If the largest exponent is just x to the first, then it'd be linear. But as soon as you have that, x squared in there, then it's quadratic. That's what we're talking about. And I want to make sure right at the outset, we distinguish between two things, okay? And that's these two statements, okay? Because they're both quadratic equations, but only one is a quadratic function. Only one are you going to be able to graph, and that's where you have x and y. This you solve. So I'm going to say something I've said very often, started off at the beginning of the year. And you don't need to write this down. Just listen. Writing it down, you've already got this all in your notes. Writing it down again, is just not going to help you. You need to understand it. Okay? Let's say I give you this. Let's say I give you this. And let's say I give you this. Okay? If I give you those 3 problems, and just listen, if I give you those 3 problems on a quiz and didn't give you any instructions, probably what would the instructions be? Not necessarily, they could vary, but most likely what would I be asking you to do? Well, the first one's not an equation, so I would be asking you to simplify. Now, yes, I know you can't simplify this problem. I'm just saying that's what I'd be asking you to do most likely. Yeah, okay, I could ask you to factor, I could do it, but most likely I'm asking you to simplify. Okay, now these next 2 are equations, but they're different. They look different, okay? So on both of them, what I'm asking you to do is find all the values you can substitute for the variable or variables that will make the statement true. But the way you do it for each of them is different. On this one, you're going to graph it. I don't want that there. Okay, and on this one, you'd solve. Okay? But whether you graph or solve, what you're doing is you're finding all the values that can be substituted for the variable or variables, like in the middle one, there are 2 variables, and the one over on the right, there's only 1 variable, that will make the statement true. Okay, what are we doing today? We're doing this one. We're graphing. So don't try and, when we do this, don't try and graph it. It's y equals x squared plus 2. Okay, just a little review first of all. Okay. I've told you how to graph these. Okay? So, for instance, here you have 5x squared equals, or plus 3, which you have the basic graph is y equals x squared. You multiply y by 5, you shift up 3. Now, I'm not going to change that, but I'm going to add something to it. Why am I going to add something to it, to what I've told you before? Because notice, like in 2x squared plus 12x minus 7, we haven't had to deal with that middle 12x yet. Okay? So that's what we're going to do. So I'm not going to contradict what we've done before, but I'm going to add to it. Okay? First of all, what do you get when you graph a quadratic function? You get this U shape. I don't think I've told it to you before. It's called a parabola. Yeah, you should know that. Okay, well, what are the important parts of the parabola? First of all, right down at the very bottom, there's something called the vertex. Okay? And this parabola has, on all parabolas do have this nifty feature called symmetry. You know, it's like, what's symmetry? It's, don't write this down. You know, you have your face, one eye's on this side of your head. Where's the other one? On the other side of your head. Okay? If your ear's over here, where's your other ear? It's not down here on your chin, it's over here. Okay? That way, once, you know, if you draw a line down the middle of your face, and if artists, I know no one's face is perfectly symmetrical, but once you draw a line down the middle of your face, one side looks at least approximately the same as the other. That's symmetry. Okay? All right. So let me get rid of this mutant-looking being here. Okay. So what do we have? Down the middle, and it's not part of the graph. That's why I'm dashing it. Remember, you make solid whatever is part of the answer, and you leave empty as much as you can, whatever's not. This is called the axis of symmetry. Or it may be called the line of symmetry, but same idea. Okay, now, I've told you you need to graph or find 5 points, okay, to graph a parabola. And you did it before, you know, using this idea, basic graph, multiply y by 5. In other words, you had the basic graph multiplied. Well, when you have this like 12x term in here, okay, it's not that simple. That's why I have to show you another way to do it. Okay, but the thing I want to get across is this. Assuming you know there's symmetry, which I hope you do by now, how many points would I need to give you, would you need to extract out of the equation in order to graph it? Well, it's not 5. You need 5 points, but you only need 3. You need the vertex and 2 more points somewhere on one side. Why? If I give you information on how to find those, then you can plot their symmetrical points on the other side. So from the equation, you really only need to get, assuming you're doing it the way I'm going to show you today. So like for this problem, you can still keep doing, this 5x squared plus 3, you can still just keep doing it that way. Okay, you need to find 3 points, providing one of them is the vertex, and then you'd find 2 other ones. So how do you graph? Well, right here, find the vertex, find 2 points by XY table. Now, may you graph the whole thing by XY table? No. If you don't show me work, am I assuming you're graphing by XY table? Yes, I am, and you may not do that. You may only find 2 points by XY table on the same side of the parabola. And then you find the other 2 points by symmetry. So you find the vertex, 2 points on one side of the axis of symmetry, and then the other 2 you'd get by symmetry. All right. Now, remember when there were, so what do you need to do? You need to be able to find the vertex, basically. The rest is pretty straightforward. Remember, there are 3 forms for the equation of a line. This is for a line, that I'm referring back now to lines. There was standard form, well, the most important one, of course, was point-slope form, then there was slope-intercept form, then there's standard form. Well, for a quadratic function, there are 2 main forms. One of them is called vertex form, and hopefully you realize it gives you the vertex. The other one's called standard form, okay? Now, what's vertex form? It's here. There'll be a number in for the K, the A, and the H. Standard form, this is it. There'll be a number where it's A, B, and C. So like if you take a look down here at the example, okay, you can see kind of what it's going to look like, okay? And notice, by the way, the K is on this side. So most of the time, the K is going to be on this side. All right, not where it is kind of in vertex form, where I have it written in vertex form. So if you notice, because you usually write it as a function, so notice the 3 is on the opposite side as the f of x. Okay, and then on the standard form, you can see what it looks like. Okay, on each one, you find the vertex. First of all, vertex form, it hands you the vertex on a silver platter. Okay, it just hands it to you. Okay? Like, take a look at this example. What's the shift? All the shift is it's telling you where the vertex is. Because on a standard parabola, the vertex would be at 0, 0. Okay? Stretching it and compressing it, which is this A value. Okay, the leading coefficient, right? That's the stretch or compress. That doesn't change where the vertex is. You can stretch and compress it all you want, and the vertex stays where it is. Okay, so what's the vertex? It's where the shift is. So look at this equation in terms of being shifted. Okay, what's the shift? Well, how do you figure out a shift? You do the same thing, as you did before. Is the number with the x or the y? Do you do the same or the opposite? Okay, so let's take a look at the h, because it's with the x, okay? Do I do what it says or the opposite of what it says? Since it's written with the x on the same side as the x, I do exactly, okay? Or sorry, not exactly. I do the opposite of what it says. So what's the vertex? H. And I'll show you an example. It should be pretty, and I realize right now it may be kind of weird. Okay, let's look at the k. It's with the y. And I do the opposite of what it says. So it's K. Okay, let's take a look at the example. What would the shift be on this problem? Well, the 1, I can't move it over with the y. And if you're not used to doing this, you got to go back to chapter 2 because this is where I had you do it. The one's with I can't move it over with the y, so it's with the x. Since it's written on the same side of the equation as the x, I do the opposite, and it's -1. Okay? The 3, I could move it over with the y, but I'm not going to. You may. And since it's written on the opposite side of the equation as the y, we do exactly what it says. Okay? I'm not going to explain shifts anymore. You should know how to do that. Okay, so what would the shift be? -1 in the x direction and 3 in the y direction. That's your vertex. Okay? That's how you find the vertex given vertex form. All right. Now, this is the weird one. Okay? And I'm not going to explain right now where this formula comes from, but you have to use a formula. You have to find A, B, and C. And how you find the x-coordinate of the vertex is you use the formula -b over 2a. Where does that come from? I can't really explain it right now. Eventually I will. You just need to know how to do it. Okay? Now, once you have the x-coordinate of the vertex, and yes, you need to memorize that formula. It's not really complicated, -b over 2a. What do? Okay, what does this mean? It means find the value of y when x is -b over 2a. Well, if I give you the x-coordinate, what would you do to find the y-coordinate? Plug it in for x. So let's take a look at this example. That's A, that's B, that's C. So to find the vertex, you'd use -b, which is -4, all over 2 times 2. That's the x-coordinate of the vertex, which is -1. Okay? And if you don't understand this, don't go on, because this is it. I'm kind of like showing you everything. I mean, I'll show you more examples, but this is pretty much about it. Okay, and then if you know the x-coordinate, how do you find the y-coordinate? Well, you take the x-coordinate and you plug it into the equation. So it'd be 2. Like, I'm going to write something on here you don't need to know. I mean, you don't need to do, so don't write this down. What does it say to do? Find the f of negative 1. Well, how do you find the f of negative 1? When you have an equation, you plug negative 1 into the equation. And again, that's not new. We've been doing that for a while. So take 2 times negative 1, quantity squared, plus 4 times negative 1 plus 5. So that's going to give us 2 minus 4 plus 5 is 3. Okay? That's how you do it. If you don't understand that, you got to talk to me, because like nothing else is going to make any sense. You got to, because what do you got to do? The first thing you got to do is find the vertex. So if you can't find the vertex, the rest of it's not going to help you. Then we're going to find 2 points by xy table on one side of the parabola, and then 2 other points by symmetry. Okay? But that's how you find the vertex. Now, before I go on, I want to mention something. Notice these 2 examples that I've given you have the same vertex. Okay? Now, does that mean they're the same parabola? Well, no, not necessarily. Let me tell you why. Let's say that's the vertex. How many parabolas can I draw that open, how many parabolas can I draw that go through that have that as the vertex? Well, of course, I can draw an infinite number. Maybe not, of course. Well, that'd be 1. That'd be another 1. But then I could also, broaden it. Then I could broaden it, make it go down. And these are lousy sketches, I know that. And you don't need to draw these. I'm just showing you something. I could make it steeper and have it go up or down. Okay? And I could just make them broader, make her steeper, whatever. I can draw an infinite number of parabolas. They all go through the same vertex. So if you take a look at these 2 examples, just the fact that they both have the same vertex doesn't mean they're the same parabola. So how can you tell if these would be the same parabola? And it's this, the leading coefficient, this value for A, okay? It's that value that stretches, compresses, reflects, et cetera, the graph, right? That's your multiplication. And notice both of these have the same leading coefficient. So they are both stretched or compressed or flipped over the exact same amount. So if they have the same vertex and they're stretched, compressed, and flipped the exact same, then you have the same parabola. So are these 2 equations the same equation? Yes, they are. Okay, why? Because they have the same vertex and they have the same leading coefficient. Okay, I'm going to write something else down. Don't do it. Let's say you had this. What would the vertex of this be? Negative 1, 3. Does that mean it's the same parabola? No, because this one's been flipped upside down and multiplied by 7. So it wouldn't look the same as one that's multiplied by 2. Okay? Now, you don't need to absolutely know that, but it will be quite helpful to know that. But there's just one more thing I want to point out to you, and it's this. Notice I'm saying these 2 equations are the exact same equation. Well, they don't look the same, do they? Well, it's kind of like this. Remember the equation of a line? You can have the same equation, but it can look like 3 different things. You can have the same line, and you can write its point-slope equation, you can write its slope-intercept equation, and you can write its standard form. Okay? You just have to know how to change the form. So what I'm saying to you is this. If I take this one on the right here, on the left, okay, and I change its form to standard form, it'll look like the one on the right, and vice versa. If I take the one on the right and I change its form two-vertex form. It'll look like the one on the left. How do you change the form? We'll do that another day. Okay, right now you just need to know how to graph it. We've got to do one thing at a time. Okay, so let's just take a look at examples. Okay, so first of all, find the vertex for these. We just have to be able to find the vertex. Okay, so this is vertex form. So it just hands me the vertex on a silver platter, negative 513. Okay, and again, you should be trying this on your own and then, ooh, brutal, brutal. Why? That's not the vertex. Why? Be very careful. There is no vertex here. It's not a quadratic equation. This is a linear equation. Today, we're talking about quadratic equations. There is no vertex. Why? Because this is linear. All right? So be very, very careful. You have to know remember, you have to know when to do something. Okay? Not just how to do it, but when to do it. And you have to make sure you're dealing with, it's just like a slope. Okay? When do you look for slope? When you have a linear equation. Like problems B, C, and D don't have slopes because they're not linear. Well, problem A doesn't have a vertex because it is linear. It's not quadratic. So you got to know what the thing looks like first. Okay, let's go on. Okay, problem B, let's find the vertex. So we have negative 18, because that's B is 18, all over 2 times A, which is 3. Okay, so that's going to give me what? Negative 18 over 6, which is negative 3. And then to find the y-coordinate, I'm going to take negative 3 and plug it in. So we have 3 times negative 3 squared plus 18 times negative 3 minus 5. All right? And it's going to take me a little bit of a calculation, so I'm going to show a little more work here than I normally would. So this is 27 minus what? That's going to be 54 minus 5. And I might have made a mistake there. I apologize if I did. But so that's going to give me negative 27 minus 5 is negative 32. And unless I made a mistake, which I wouldn't doubt, that'll be the vertex for that parabola. Okay, here, what's the vertex going to be? Well, we have negative b. B is 1, so it's negative 1 all over 2 times a, which is negative 1/6. And so you should cancel the 2 and the 1/6. That gives me 3. And negative 1 over negative 1/3 is 3. And if you don't know how to do that, I don't know. It's just simple fractions. That's all I can really say. And so we'll take 3 and we'll plug it in. So we have negative, sorry, I'll do it up here. Okay, so we have negative 1/6 times 3 squared, which is 9, plus 3, plus 5. Okay, so what's that? That's going to be negative 3 halves plus 8, basically. So we'll say it's 3, comma, what? 6.5. Okay? Or if you want to say 13 halves, that's fine. It doesn't matter. Okay, now what's the vertex here? Well, what's A? A is always, it's kind of like, look up here. Where's A located? It's not first, okay? It's next to the x squared. Where's B? It's not second. It's next to the x. What's C? It's the constant. So in other words here, if you take a look at, let's take a look at problem B. What if I had given you this? G of x equals negative 5 plus 3x squared plus 18x. Well, first of all, you'd want to rewrite it in this, like we have it here. But A, B, and C are still the same. A would be 3, B is 18, and C is negative 5. It's not like that they're first, second, or third. It's, are they next to the x squared, are they next to the x, or are they the constant? No variable. Okay, so here, what's A? 2. Well, this is C. Well, what's B? B is nothing. B is 0. because there's nothing in the middle. This is the same as like saying 0x. So we have negative b, which is negative 0, all over 2 times 2. Okay, well, 0 over anything is 0. And then, so we'll take 0 and plug it in. 2 times 0 squared minus 3 is negative 3. Okay? And by the way, I know I'm dealing with this, the new way. This problem D could eventually, could you do this by multiplying by 2, multiplying y by 2, and then shifting down 3? Yeah, absolutely. Again, I'm not changing what we did before. That still works perfectly. That's the way I do it. I'm just adding to it and showing you another way, okay? And why do I have to do that? Because of, in case that x term is in there. But if the x term's not in there, you can go ahead and do it the old way. That's fine. Okay, so let's take a look at this. First of all, something I want to point out. I'm going to do this one way, but and I'm going to go through it real quickly because you sure didn't know how to do this. You can do this the old way, okay? What do? Multiply y by 2 and shift 1 to the left and 3 up. That's fine. So I'm gonna do this real quick. I'm not gonna put the basic graph on here, but you'd multiply, the graph by 2. And you should already know how to do this. That's why I'm going through it fairly quickly. It doesn't mean you can't come in and ask me how to do it, but you got to at least, review your notes if you don't remember. And then I'll go left 1 and up 1, 2, 3. Left 1 and go up 1, 2, 3. Left 1 and go up 1, 2, 3. Now, if I take these points up here and go left 1 and up 3, then you go off the grid. So, probably what you'd really have to do here, even though I don't want to spend a lot of time on this, is you'd have to go back and relabel everything by 2s, okay? Because I can't get it on the grid. So this would be 16, 16, 16, and negative 16. So if I multiply by 2, that would be here, 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 and here. Okay, and then I'd go 1 left and up 3. So 1 left and up 3 would be right there. And then take this and go 1 left and up 1, 2, 3. Then take this one, go 1 left and go up 1, 2, 3. Then take this one and go 1 left and go up 1, 2, 1, 2, 3. And then take this one and go 1 left and go up 1, 2, 3. And again, if you have questions on that, you can come and see me because I'm not trying to review what we did before. I'm just trying to point out to you, okay, that we could do it that way. I'm not changing what we did before. I'm just adding to it. So let's do it the way I'm showing you today. But you know what? I don't care what, either way is perfectly all right. Okay, make sure you understand that. They're both perfectly good methods. Okay, but I'm just going to do it, since you should already know how to do this, let's do it the way I'm showing you today. Okay, so let's find the vertex. So we have negative 1, comma 3. Okay, so we'll plot negative 1, comma 3. And so what do? Plot. You know what? I think we're going to have to relabel the axis on this one too. Well, actually, let's just do it. Okay, so now I'm going to find only 2 points. I don't care if the 2 points are on the right. I don't care if the 2 points are on the left. I'll pick the ones on the right, okay? So this is your axis of symmetry, which is not part of the graph, but that's going to be the middle of your graph, and I strongly suggest you dash that in. You will avoid many mistakes by dashing in the axis of symmetry. Okay, so what's the first, let's pick integers. What's the integer just to the right of negative 1? Well, it's 0. What's the integer to the right of that, and it'd be 1. Okay? So let's plug in 0. So we have 2 times 0 plus 1 plus 3. And what does that give me? That gives me 2 times 1 plus 3 is 5. So we'll plot 0, 5. And I just want to point out something. I probably shouldn't have plotted that, but anyway. Now 2 times 1 plus 1 squared plus 3. So that's 2 squared, which is 4, times 2 is 8, plus 3 is 11. Now notice, I don't have 11 on this graph. So you might want to find these points before you actually start labeling your graph, because now I've got to go back, before you start drawing it, because now I've got to go back and relabel, because this thing only goes to 8. Remember, if you don't label it 1, 2, 3, we're agreeing it's by ones. So again, I'm going to do this to 16. Okay, so I'll plot, the vertex was -1, 3, and the axis of symmetry is here. Okay, and that's our vertex. Okay, we have 0, 5, which is right there, and 1, 2, 4, 6, 8, 10, 11. Okay, so what would be the symmetrical point? Well, for 0, I'm going to put the symmetry points here. Okay, for 0, what would be the x-coordinate on the other side of the line of symmetry? It'd be -2. Okay, and it's going to have the same y-coordinate, which I don't need to calculate it. And for 1, I blew that, didn't I? Shoot me. I plotted it at 2, 11. It should have been right here. 2, 4, 6, 8, 10, 11. That's 1, 11. Yeah, so I got to be more careful. What's the one on the other side? It's going to be at -3. And it'll have the same y-coordinate. And then you draw your graph. Okay? Now, I'll go through more of this, but that's basically what you do. Now, I want to point out something. If you go back and look at the way I did it, or if you do it yourself, where you did it by multiplying y by 2, and then shifting 1 left and 3 up, you'll get the exact same graph. It doesn't matter how you do it. Okay? Either way is fine. All right? Okay. Let's take a look at this one. This one is in standard form, so let's find the vertex. And again, at this point, I'm going to kind of have to go through it quickly because otherwise, this video will end up to be 2 hours long. So, there's a lot here, so you may have to listen to it a couple times. So let's use -b all over 2 times a, which is going to be 4. And to find the y-coordinate, I'll plug in 4. Okay? So what's that going to be? Okay, we have -16 plus 24 plus 2. So we have, 26 minus 16, so we have 4, 10. So again, I think we're going to probably have to relabel our axes. Okay? So let's just try sketching what's there, though, and then we'll worry about relabeling. So we've got 4, 1, 2, 3. We've got 4, 10. All right, let's just make a sketch of it here. Okay, so we have 4, 10. We don't have to do it on the graph. Okay, so I don't care whether you pick them on the right or left. What are some x values and I'll pick them, I like to pick them closer to the axis. So what are the x values I'm going to go to the left side of the axis of symmetry this time. Okay? to the left of 4? Well, there's 3, and then if I keep going left, that's 2. All right, fine. So let's plug them in. So we have negative 3 squared plus 8 times 3 plus 2. Okay, so what is that? That's 24 plus 2 minus 9. So that's 26 minus 9 is 17. And then if I plug in 2, again, I'm just plugging it into the equation. Minus 2 squared plus 8 times 2 plus 2. Okay, so that's 16 plus 2 is 18 minus 4 is 14. Okay, well, okay, 3's on one side, right? So what's on the other side? 5. And it'll have the same y coordinate. 2's on one side. And so what's on the other side? 6. Just symmetrical point. And it'll have 14. Okay, so I know I have to at least go to, there's something wrong here. Okay, how do I know there's something wrong? Because if it's 4 comma 10, 3 comma 17 would mean the graph goes up. And you see how you have a leading coefficient here that's negative? The graph should be going down. Okay, so somewhere I made a mistake here. All right, let's see where it is. I mean, that's okay, it happens. Okay, so we have negative b is negative 8 all over 2 times negative 1, which is 4. And then we have negative 16 plus, oh, that's why. This should have been 32. 8 times 4 is 32. Okay. Hopefully you caught that. I wish I had got it. Okay. But you notice how you can kind of look at it and say, okay, the fact that it's negative means it should be going down. My graph wouldn't have been going down. Okay, so that's going to be 16 plus 2 is 18. Okay, we're good there. Okay. All right, so I don't know. What does it look like here? You know, usually you want to plot the x and y axes the same, like everything, like up on this one, I had 16 in each, direction. But sometimes it's just easier if you plot them differently. You don't want to do that. But if it seems to make sense, go ahead. So let's go ahead here. I don't know. It seems we want to go up to about 20 on the y, and we want to go to 6 or so on the x. So we can probably do these by ones. The x's by ones. 1, 2, 3, 4, 5, 6, 7, 8. So the corner would be 8. Okay, but if we want to go up to like at least 20, probably we'd, and it's a judgment call here. You could do it by, we have 8 things. You could do it by 3s. So we'd have 3, 6, 9, 12, 15, 18, 21, 24. So that's by 3s, all right? And by the way, if you want to do this by 2s, then this could be 16. That's fine too. Doesn't have to be the same. You just have to mark them. Once you mark the axis, you got to mark both of the axes, okay? Preferably both the same. Could you do it 24 each way? Yeah, you could. It just might be a little hard to graph it. So I think I'm going to do it by 8, but that's, I don't know. I'll just leave it 16. 8 or 16, either one of those is good. In other words, if you do it by 1s, it's 8. If you do it by 2s, it's 16. Let's go ahead and do that. But if you do it by 1s, that's fine. Okay, so what's our vertex? Our vertex is 4, 18. So I'm going to go 2, 4 on the x-axis and up 3, 6, 9, 12, 15, 18. That's the point, 4, 18. Okay? Now, on one side, I'm going to plot 3, 17, which is right there. And on the other side, oh, sorry. Good idea to put the axis of symmetry through. I have to admit, it's kind of negligent there. Okay, on the other side, it'll be 5 comma 17. Okay, and then I'm going to plot 2 comma 14. Okay, so this is 2 comma 3, 6, 9, 12, and 14 would be right about there. And then the symmetrical point over here is 6 comma 14. So maybe these ones, the 3 comma 17 and 5 comma 17, I probably should have plotted them a little higher. They're okay where they are, but remember, okay, so it's probably about there and there. I don't know. I'm not that concerned with it being like perfect. Okay, and then just draw it as best you can. Yeah, I hate this thing when it starts drawing lines for me when it shouldn't be drawing a line. Okay, so, it's going to be curved. Something like that. Again, just do the best you can. Okay? All right, let's take a look at this one. And again, I just want to go through a lot of examples for you. I realize this is taking a lot of time, but, I just want to make sure you know what to do. Okay, so we have for the vertex, we have negative 4 all over 2 times negative 2. Okay, so that gives us 3 negatives, gives us a negative, so that's negative 1. Okay? And then we have, we're going to plug negative 1 in, so that's negative 2 times negative 1 squared minus 4 times negative 1 plus 1. Okay, so that's going to be 1 squared is, negative 1 quantity squared is 1 times, so that's negative 2, plus 4 is plus 2, plus 1 is 3. All right? Okay, so this looks like it's probably going to work, but let's just draw a quick sketch of it. So we have negative 1, 3, and I know this is going to be opening down, so we're probably okay. There would be the axis of symmetry. So on one side, I'm going to go again towards the x-axis. On one side would be 0, and next to that would be 1. Okay, so let's plug in 0. So we'd have 0 minus, negative 0, I guess, minus 0 plus 1 is 0 comma 1. That's pretty simple. And if we plug in 1, we get negative 2 times 1 squared minus 4 times 1 plus 1. I'm going to stop making these calculations pretty soon. You should know how to do it. And so that's going to give us negative 2 minus 4, which is negative 6, plus 1, which is negative 5. Okay, so those numbers all look pretty good. So we've got negative 1 comma 3, axis of symmetry. Okay, so we've got 0 comma 1 and 1 comma negative 5. Okay, so what would your symmetrical point be? On the other side of negative 1 will be negative 2. So that's going to have a y-coordinate of 1. And on the other side of the axis of symmetry, we'll have negative 3. And negative 5, which is right there. And then we'll draw it as best we can. Okay, and that one should be pretty straightforward. Okay, I believe this, no, it's not the last one. Okay, again, you can do this by multiply y by a half, shift 1 to the left, and go down 5. And if you do that, you'll get the exact same. I'm not going to do it that way. Not that it's a bad way. It's a great way to do it, and I encourage you to do it that way. But I'm going to do it the new way just so you can see what's happening. Okay? So we have the vertex. Again, this is vertex form. Is negative 1 comma negative 5. Let's draw a sketch of it. We have negative 1, negative 5. Axis of symmetry. So We've got 0 on one side and 1 after that. So let's plug in 0. So we have, and I'm going to do this, just talk through it. 0 plus 1 squared is 1 times a half minus 5 is minus 4.5. And if you plug in 1, 1 plus 1 is 2, squared is 4, times a half is 2, minus 5 is negative 3. Okay, so we should be good by ones here. So we've got negative 1, negative 5, 0, comma 4.5, negative 4.5, sorry, and 1, comma negative 3. And then our symmetrical points would be on the other side is negative 2 and negative 3. So it's negative. So I apologize. See, I've already put the axis of symmetry on the little sketch over here, and that's how come I know where it is. And so we've got that point there and that point there. And if you had done this by multiplying y by a half and then shifting 1 to the left and 5 down, you'd get the exact same graph. Okay, here. Can you do this by multiplying y by 2 and then shifting 3 up? Yes, and I encourage you to do it. It's the easiest way to do it. Okay, I'm just going to show you the other way. That's all, because I haven't done it the other way yet. I've done it, by multiplying and then shifting. Okay, again, your b value is 0 here. So negative b is negative 0 all over 2 times 2. Okay. So that would be 0. If you plug in 0, you get 3. So your vertex is 0, 3. Let's just make a sketch of it. So we have 0, 3. Axis of symmetry is straight down the y-axis. So we'll just pick 1 and 2, and then your symmetrical points will be negative 1 and negative 2. So if I plug in 1, 2 times 1 squared plus 3 is 5. 2 times 4 plus 3 is 7. So we have 0, comma 3, 1, comma 5, I did something wrong there. It can't be 7. I'm sorry. I apologize there. It's not 7. It wasn't going to give me a parabola. Okay. 2 squared is 4, times 2 is 8, plus 3 is 11. So we're going to want to do this by 2's. Okay, so we'll just do everything by 2's. So this is going to be 16, this is going to be 16. Okay, so we have 0, comma 3. 1, comma 5, and 2, comma 11. 2, 4, 6, 8, 10, 11. And then the symmetrical point would be negative 1, 5, and negative 2, 11. And again, if you did this the other way, you'd get the exact same graph. And probably a little easier, but whatever. Okay, I'm not going to belabor this anymore. That's it. Bonsuelo, if you have any questions, ask me, but make sure you've gone through these examples first. Have a good day, everybody.